Good morning, everyone. I welcome you all to India's largest e-learning platform, Unacademy, and I welcome you all to my session, Antennas MCQ series, and I welcome you all to the Gate Conqueror channel. This series is going to be a very, very important series, dear. We are into Antennas MCQ series, comprehensively discussing on antennas and covering the MCQs useful for our competitive exams. This is part 10. Before we move in, let me introduce myself. I am GC Reddy, having 15 plus years of experience in teaching, guiding and mentoring GATE and DSC aspirants. I work as motivation speaker from the past 12 years, Pan India, an expert in field theory and communications. Fine. And this is the official Telegram channel for the Gate Conqueror channel. This is the official Telegram link for the Gate Conqueror channel, where you can access all the faculties of the Gate Conqueror channel, including the legendary KM Rao sir. So we as a team, we can access all the team members of the Gate Conqueror channel. And the good news for all the Gate Conqueror the followers is that we had increased in number now. 3 more educators have joined us, and within a couple of days, 1 new educator for our particular team, and an alumni of IIT with the name of Archit. Archit sir will join us, and he will also start classes very, very soon. So just stay tuned, and we are very much determined to complete GATE and ESC 2023 syllabus comprehensively. The target is to complete GATE and ESC 2023 syllabi comprehensively. So now we have numbers with us. Now we have more faculties with us. So very easily we will try to cover comprehensively GATE and ESC 2023, because for 2023 there is a lot of time for us. So let us target this GATE and ESC 2023 now, and I am more than confident that we can easily, comprehensively complete the syllabus for GATE and ESC 2023. Is that clear? So also please tell your friends to join the channel, so that they'll get some comprehensive syllabus coverage like you never get in on any other channel. You may wonder what is the speciality of our channel. I'll soon explain. We are into Antennas MCQ series, part of EMFT. Part of EMFT. EMFT syllabus has total of 5 modules, in which module 1 is elements of EMF theory. Module 2 is EM wave propagation. Module 3 is transmission lines. Module 4 is waveguides. Good morning, Srikanth. And module 5 antennas and optical fiber communication. Now dear, for elements of EMF theory, we already have a playlist uploaded with 40 videos and 50 hours of lecture. Generally dear, on any YouTube channel, the maximum number of hours that you can find for elements of EMF theory is not more than 10, maximum 10. I've never seen any YouTube channel having content more than 10 hours for elements of EMF theory. Against that, what we have done is not just 20 or 30 hours, with 40 videos, we got 50 hours of content. That's really appreciable thing. So I can say that in and out, everything about elements of EMF theory will be covered. What we covered, I'll explain very soon, don't worry. So that playlist is there. You can forward this playlist to your friends. Using this playlist, if you are from electrical, you can prepare for GATE and especially for engineering services. Generally, when you design some playlist or when you do some videos, mostly in YouTube, on any YouTube channel, they prefer to do it for the content of GATE, which is relatively easy. But for engineering services, we need to do all the derivations kind of stuff, which is very, very difficult. But the uniqueness of this playlist is like this particular playlist is useful for both GATE and engineering services, because I covered basically complete theory. You can just go through, you'll understand. I had completed complete theory, all the derivations, each single of them, all the derivations, almost like 100 derivations I had done. All the derivations we had covered, all previous year question papers, GATE and engineering services, lots and lots of practice questions. What else you want? So, if you are from electrical background, then this playlist will be useful for both GATE and engineering services. If you are from EC, it will be useful for both GATE and engineering services, but not the complete syllabi, because this is only a part of the syllabus. But of course, for both electrical and EC people, it will comprehensively cover GATE and engineering services. So that thing you need to understand. This we had covered in elements of EMF theory. EM wave propagation, we created one more playlist with 9 videos and 18 hours of content. Almost like around 90% of the syllabus of this particular module is covered here. What we had covered, what we need to cover up, that I'll explain in detail. And today at 9 p.m. Today at night 9 p.m. Again, what we do is we take part 10 for this and try to cover up the remaining syllabi from EM wave propagation. Then, when for transmission lines and waveguides, this both transmission lines and waveguides we need to cover, not yet completed. Antennas we had covered using antennas and wave propagation concepts, useful for both GATE and engineering services. We covered in the playlist named Antennas Maha Marathon series, where we created a playlist, 18 videos, and 38 hours of content is there. So overall, we have covered 50 plus 18 plus 38. 106 hours of content is already recorded related to EMFT. Now, in this 106 hours of content, what I had covered, that I'll explain in detail, which is a part of comprehensive completion of syllabus for EMFT subject. One second. Fine. Okay. Is it clear? So what I had covered in these 106 hours, I'll explain in detail. So one thing is very sure, dear. This EMFT full comprehensive series or these playlists will be useful where we have covered EMFT comprehensively. There is no doubt in that. Because I had seen people covering EMFT, complete EMFT in 30 to 35 hours. Against that, already we have recorded 106 hours of recording, and still around 100 to 114 hours more recording I'll do, or more hours of content I'll try to deliver in covering just EMFT. So I can say dear, around 220 hours of content. It's not a joke. 220 hours of content only for EMFT. That's the level of content that you get on the Gate Conqueror channel. Just because that you people are not aware of what valuable content that you have on our channel, I'm trying to explain. If you are targeting EMFT, what content do you have on our channel? That I'm trying to explain, so that you can rely on the Gate Conqueror channel for your preparation for Gate and ESC 2023 with no doubt. So what I covered, in module 1 is elements of EMF theory. Before we have started module 1, we covered a prerequisite that is required to understand EMF. So that's the speciality of this playlist. Module 1 has a playlist with 40 videos and 50 hours of content. The speciality of this playlist is we have this very important, very rarely explained prerequisite content that is required for understanding of our subject. In prerequisite, we had covered basics. Under basics, divided the basics into two parts. Elements of vector calculus, and coordinate system. Elements of vector calculus and coordinate system. Under elements of vector calculus, we covered concepts like scalar, vector, unit vector, addition of vectors. Under addition of vectors, dear, see, like just like numbers, we cannot add these vectors also, am I right? So basically there will be rules for us to how to add these vectors. So we have seen how to add these vectors, and what are the two kinds of methods where we can add these vectors, dear? What are the two methods where you can add these vectors? Anyone? The two ways in which you can add the vectors: parallelogram law and head to tail rule. Also called as triangular law. So these are the two ways in which you can add these vectors, which are in detail explained in this playlist. If you want to go for in detail explanation about what is parallelogram law and what is triangular law or what is head to tail rule, please go through the playlist, which contains 40 videos and 50 hours of lecture, where in detail I explained about addition of vectors with some wonderful examples. Please go through it. Then we had seen basic laws of vectors. Can anyone tell me what are basic laws of vectors, dear? What are basic laws of vectors? Commutative law, associative law, and distributive law. In commutative, associative and distributive laws, we have seen commutative law of addition and commutative law of multiplication. Similarly, we have seen associative law of addition, associative law of multiplication, distributive law of addition and distributive law of multiplication. Especially in distributive law of multiplication, there is a very important thing that I discussed, Without going through this playlist, if anyone can answer what is the speciality of distributive law of multiplication, please post in the comment. Post in the comment section. What is the speciality of the concept called distributive law of multiplication? If you cannot answer, then you can please go through this playlist. You'll get some wonderful answer for distributive law of multiplication, dear. Before you go through, I request you to just try once and know what is the secret behind distributive law of multiplication. Then we had seen multiplication of vectors. Under multiplication of vectors, we are seeing dot product, are also called as scalar product, because the dot product of two vectors results in a scalar quantity. Thereby it is also called scalar product. So we had seen dot product, basic rules of dot product, the basic laws applied for dot product. And also we had seen cross product or vector product. Cross product results in a vector quantity. Therefore, cross product is also called as vector product. And also we had seen in detailed explanation about multiplication of vectors and which laws they follow, like commutative, associative and distributive, and why they follow, why they do not follow. All this very, very interesting concept in detailed explanation are given in this particular playlist. Please go through it if you want to know about the multiplication of vectors. Then we had seen the del quantity, the del operator is a vector differential operator, a spatial derivative operator, and we had seen its properties. Some wonderful examples were discussed under the concept of del and its properties. Please go through it. Then in the second part of the basics, we went for coordinate system. How many coordinate system do you have, dear? Anyone? Triangular law, very good. Yes. How many coordinate system do you have? XYZ. What it is called? XYZ is called what? What is the name of the coordinate system? What is the name of the coordinate system? Coordinate system Cartesian coordinate system are also called as rectangular coordinate system then we have cylindrical coordinate system which is also called as circular coordinate system and we have seen spherical coordinate system. Cartesian coordinate system, coordinates are x, y, z. Cylindrical coordinate system, the coordinates are rho, phi, z. In spherical coordinate system, the coordinates are r, theta, phi. Under each coordinate system, what we had seen is we have defined the coordinates and we have defined their range for each coordinate system. Then what we have done is completed a concept called point transformation. What is point transformation is? Point transformation is a concept where we understand how to convert a point from one coordinate system to another coordinate system. So again, in detailed explanation of point transformation, you can please go through the playlist of 40 videos and 50 hours of content. Very clearly I explained all the things about point transformation here, which is comprehensively covered. Then we had seen about unit vector relations. What are unit vectors and how they are related? Very, very important topic. So many number of times applications of this has been asked in engineering services. So again, very in detailed explanation about the unit vectors and the unit vector interrelation. Very, very rarely find on any YouTube platform, I can say, is explained in detail here. Then we had seen how to write differential length, differential surface and differential volume in all the three coordinate systems. How to write these things in all the three coordinate systems we had seen. Then along with this DL, DS and DV in all the three coordinate systems. Again, this is a very important topic here. Very difficult, very important topic that I explained it with so much of simplicity into it. Just go through it, you'll have some wonderful shortcuts. Actually, this concept is the route through which you learn EMF. And after this lecture, in that video, you will feel that yes, EMF is easy. So you'll be learning how to write differential length, differential surface, and differential volume in all the three coordinate system. Then also we had seen divergence, curl, gradient, and Laplacian. How to write divergence, curl, gradient, and Laplacian in all the three coordinate system. Again, this is a wonderful topic here. This is a base topic which will make your EMF look very simple. And for this basics, only for basics I took 15 hours. 15 hours only I spent on basics. You can understand at what level we have discussed these basics, and we have solved all the previous year questions, many practice questions also that appeared from the basic concepts. So this was the prerequisite that was required for elements of EMF theory. Then after 15 hours of lecture, we started elements of EMF theory there. Under elements of EMF theory, it covers some main topics like electrostatics, magnetostatics. Both these, electrostatics and magnetostatics, are covered under subtopic static field theory. Elements of EMF theory, the technical part I divided into two parts: static field theory and time varying field theory. Under static field theory, we have covered the main concepts like electrostatics, the study of static charges, magnetostatics, study of static magnetic field, which is because of movement, uniform velocity of static charges, which produces DC current. So again, in detailed explanation about electrostatics and magnetostatics we are done, and through which were derived Maxwell equations, for static fields. Under Maxwell equations for static fields, there is the first equation, closed surface integral of d dot ds is equal to volume integral of rho v dv. This is integral form. Differential form, del dot d is equal to rho v Source Gauss law. That's the first equation. Source Gauss law for electric fields. Second equation, closed loop integral of E dot dl is 0. Closed loop integral of E dot dl is 0. Differential form, del cross E is equal to 0, or curl of static electric field is 0, implies the conservative nature of electric field. This is a property called conservative property of electric field, which shows that static electric field always move in straight lines. Their curl or rotation is 0. These two equations are from electrostatics. Then we have seen some third equation. Closed loop integral of h dot dl is equal to surface integral of j dot ds. This implies del cross h is equal to j. This from Ampere's law. Fourth equation, closed surface integral of E dot ds is 0. Differential form, del dot b is equal to 0. Source, non-existence of magnetic monopole. Non-existence of magnetic monopole, also called as Gauss law for magnetic fields. So these are the four equations here, which are called Maxwell equations for static fields, which we have discussed under static field theory. This we have discussed under static field theory. Okay. And the third equation and the fourth equation are from magnetostatics. The third and fourth equation are from magnetostatics. Under static field theory, the main laws that we had covered under electrostatics is Coulomb's law, which is defined or which defines force between 2 point charges. Then we had extended its application for line charge, surface charge, volume charge, derived the expressions which are useful for engineering services. Very important, Coulomb's law, which is a generalized law which governs electrostatics. Again, in detail explanation, all the theory, all the derivations, previous year question problems, practice problems, image concept, image charge concept, I mean to say. All that we discussed. Method of images, in detailed explanation was given. In Coulomb's law, which is a generalized law that governs electrostatics. And it's in Gauss law, which is a special law that governs electrostatics, which can be applied only under special conditions where a Gaussian surface is defined. And a Gaussian surface is one which is symmetric with respect to charge distribution. Such surface is called as Gaussian surface. Only when the Gaussian surfaces are defined, we can apply Gauss law. For example, for point charges, the Gaussian surface is a sphere. For line charges, it is cylinder. Similarly, for each of the charge distribution, there are Gaussian surfaces which are symmetrical with respect to charge distribution. So again, Gauss law, again in detailed applications for point charges, line charges, surface charges, volume charges, their derivation, their application, previous year questions, the methodology for solving it, everything again in detail we have discussed in Gauss law. In magnetostatics, we discussed the generalized law called Biot-Savart law, which gives you the magnitude of magnetic field when a DC current is flowing in a given conductor. This is again the generalized law that governs magnetostatics. Besides this, we have seen Ampere's law. This is a special law which governs magnetostatics. And for Ampere's law, we need to define an Amperian path. In order to apply Gauss law, we need to define Gaussian surface. And to apply Ampere's law, we need to define Amperian path. Again, Amperian path is something which is symmetric with respect to current distribution. Whereas Gaussian surface is a surface which is symmetric with respect to charge distribution. Clear? So these important laws we have seen, namely Coulomb's law and Gauss law. Coulomb's law is the generalized law that governs electrostatics. Gauss law is the special law that governs electrostatics. And we have seen Biot-Savart law and Ampere's law. Biot-Savart law is generalized law that governs magnetostatics, and Ampere's law is the special law that governs magnetostatics. And Gauss law can be applied only when a Gaussian surface is defined, and Ampere's law can be applied only when Amperian path is defined. A Gaussian surface is one which is symmetric with respect to charge distribution, and an Amperian path is one which is symmetric with respect to current distribution. Clear? In static field theory, any doubt, let me know. If you have any doubt, please let me know. If you are having any doubt, please let me know. Any doubt? Yes. Please let me know, dear. Okay. So besides these concept, besides these laws, and besides deriving Maxwell equations for static fields, we've also seen some very important concepts. Poisson's and Laplace equation, Poisson's and Laplace equations. Again here, Poisson's and Laplace equation in all three coordinate systems with their applications. Some really wonderful topic this is. We covered it like never before on any other channel. So, mind-blowing concept, especially applications, appreciable applications. Poisson's and Laplace equations are never seen before questions. Very important models were covered under Poisson's and Laplace equations. Then we have seen boundary conditions. Under boundary conditions, we have discussed dielectric boundary condition, and dielectric conductor boundary condition. Under boundary conditions, under dielectric boundary condition, there is a boundary condition that is prevailing between two dielectrics, and a boundary condition is required to estimate the field on the other side of the region when the field on your side of the region is known. So, dielectric boundary conditions, condition on the boundary between two dielectrics with the help of Maxwell equations, and taking the boundary, the condition that is prevailing at the boundary, we derived some boundary conditions which you got it as ET1 is equal to ET2. Tangential component of electric field intensity is continuous across the boundary of discontinuity. What it is? Tangential component of electric field is continuous across the boundary of discontinuity. That we have discussed. ET1 is equal to ET2 means what? The tangential component of electric field is continuous across the boundary of discontinuity, and it is unconditionally continuous. It is unconditionally continuous. Then we had seen dn2 minus dn1 is equal to rho s. dn1 is equal to dn2 if and only if rho s is 0. So what is the boundary condition? The boundary condition is normal component of electric flux density is continuous across the boundary of discontinuity if and only if the surface charge density that is deliberately placed on the boundary is 0. This is conditionally continuous. It is conditionally continuous, or this is continuous only under the condition rho s is equal to 0. Ht2 minus Ht1 is equal to K cross An. This is vector notation. In scalar notation, Ht2 minus Ht1 is equal to K. Where K is the surface current, implies Ht1 is equal to Ht2 if and only if K is equal to 0. Where K is the surface current that is deliberately placed on the boundary surface, and this boundary condition implies that the tangential component of magnetic field intensity is continuous across the boundary of discontinuity, and this condition is true if and only if K is 0 or surface current is 0. Not just like this, dear. Around 2 hours of lecture I took on boundary conditions. We just not given this, we are derived. And if you want in detailed explanation about this boundary condition, please go through the playlist. Clear? Then let's see, Bn1 is equal to Bn2. Normal component of magnetic flux density is continuous across the boundary of discontinuity, and this is unconditionally continuous. These are dielectric boundary conditions. Not only we are defined, but also we are derived, and some wonderful applications, problems, numerics we have done. Previous year question papers we have solved. Some practice questions we have done. So overall, out and out, exclusively we had covered up this dielectric boundary conditions concept here. And now if one of the dielectric is replaced by a conductor, we have a condition called dielectric conductor or dielectric perfect conductor boundary condition. If this is dielectric boundary condition, this is region 1, this is region 2. This is having epsilon 1, this is having epsilon 2, this is having mu 1, this is having mu 2. But in dielectric conductor boundary condition, one of the region will be converted into perfect conductor. Now there is only one region. So this is epsilon, this is mu. Velocity is v here. This is called dielectric conductor boundary condition. And we have also done some exclusive analysis on the behavior of perfect conductor, and we concluded that none of the fields which are varying with none of the fields can exist within a perfect conductor. So trying to make them as 0, then we got the conditions like E tan is equal to 0. Tangential component of electric field intensity on the surface of a perfect conductor is 0. This is one of the boundary condition. So always on the surface of perfect conductor, the tangential component of electric field will become 0. The second, d normal, one of the electric flux density will become 0. So d normal is equal to rho s. Normal component of electric flux density is equal to the surface charge density that is deliberately placed on the boundary. Then H tan is equal to K cross An. One more boundary condition. One more boundary condition. B normal is equal to 0. These are called as dielectric conductor boundary conditions. Again, I am telling you, in detailed explanation about these boundary conditions are exclusively we are discussed. Exclusively we are discussed in module 1. Dielectric conductor boundary conditions. Then other than these boundary conditions, but also exclusively discussed on wonderful topic called capacitors and inductors. types of capacitors, types of inductors, their derivation, applications, specially applications for parallel plate capacitor, coaxial cable capacitor, spherical capacitor. Some wonderful applications we have done. Previous year question papers were solved. So many practice questions we have done. One of my favorite topic. So much of weightage, so much of importance in competitive exam. That exclusively we had covered those particular concept of capacitors and inductors. We had seen both types of capacitor, types of inductors. Exclusively. We discussed concepts like solenoid and toroid also. So all this in static field theory. And in time varying field theory, if you drop Maxwell equations, for time varying field theory, the first equation is closed surface integral of d dot ds is equal to volume integral of rho v dv. There is no change, which is same as that of static field theory. Differential form is also same. Del dot d is equal to rho v. Source, Gauss law. Source is Gauss law for electric fields. The second equation, yes, will modify closed loop integral of E dot dl is now no more becomes 0, because if closed loop integral of E dot dl is becoming 0, then the differential form we are getting del cross E is equal to 0. Curl of electric field is 0. Orientation of electric field is 0. Yes, static electric field will move in straight line, therefore orientation of electric field will be 0. Or static electric field is conservative in nature, irrotational in nature, but not time varying electric field. Therefore, for time varying electric field, the RHS must be not equal to 0, which is equal to surface integral of minus dou b by dou t dot ds. From where we derived this? From Faraday's law. From Faraday's law we have derived this, which will be discussed in detail in the playlist. Then the third one, closed loop integral of h dot dl is equal to surface integral of j plus jd dot ds, where j is conduction current density given by sigma E, jd is displacement current density given by dou d by dou t. Differential form del cross h is equal to j plus jd, where j is conduction current density depends on conductivity of the material given by sigma E, jd is displacement current density depends on time varying electric field given by jd is equal to dou d by dou t, and this is from Maxwell contribution. Also called as inconsistency of Ampere's law. Anyways, again, in detailed explanation about these concepts are given in this particular playlist of 40 videos and 50 hours. Please go through them. Then closed surface integral of b dot ds is 0. From this again del dot b is 0. This is called Gauss law for magnetic fields. Now here again, equation 1 and equation 4 are same as that of Maxwell equations for static fields. Only 2 and 3 will vary based on Faraday's law or Maxwell contribution, or it is also called as inconsistency of Ampere's law. Again, the very important one, we have done previous year question papers, solved all the numerics related to time varying field theory, which will give you Maxwell equations for time varying fields. These are Maxwell equations for time varying fields. Combining them, you will get wave equation. which will be a stepping stone for understanding module 2, which is EM wave propagation. So this we had completed. These are the main important topics we had completed. Some wonderful series or playlists we had created with 40 videos and 50 hours comprehensively covering module 1, elements of EMF theory. So, my dear students, you can rely on the Gate Conqueror channel for elements of EMF theory, which is complete syllabus for electrical. So, electrical people blindly follow this playlist, this one playlist. Your EMF syllabus for Gate and ESC will be covered in this particular series of elements of EMF theory, dear. Please make a note. After the module 1 has been covered comprehensively, started module 2. EM wave propagation. Here we have 9 videos. It's total of 18 hours. The total of 18 hours, dear, which were discussed under EM wave propagation. How EM waves will propagate in free space, in materials, in good conductors, good dielectrics, and perfect dielectrics, or in any other medium. That analysis is done in this particular concept called EM wave propagation. We covered it under EM wave propagation. Under wave propagation, yes, seriously. Under EM wave propagation, where we had released 9 videos and a total of 18 hours, we had covered concepts like EM wave propagation, in free space. Free space means how much is sigma? Sigma 0, epsilon r 1, and mu r is 1. Let's see. EM wave propagation in free space. As I told you, free space means sigma is 0, epsilon r is 1, and mu r is 1. And also before that, we had combined these two equations. From one is from Faraday's law. Del cross E is equal to minus dou B by dou T. And the other, del cross H is equal to J plus JD. J is conduction current density, sigma E. JD is displacement current density, dou D by dou T. We covered this. Just a second. Yeah. So by combining these two equations were derived Helmholtz equations. Helmholtz equations are nothing but wave equations which will tell you the propagation of the wave. So again, some wonderful, beautiful derivations are there. How we got that? So we got Helmholtz equation like del square E is equal to gamma square E, and del square H is equal to gamma square H, which are Helmholtz equations. We got these Helmholtz equations by solving these Maxwell equations. So this is nothing but the wave equation. It will tell you how the wave will propagate. So seriously, before moving into the EM wave propagation in free space, we had a discussion on what is a wave and how a wave propagates in free space, or what is the characteristic of the wave. What is the characteristic of the wave? If you want to call something as a wave, what are the two important things that you need to understand? One is that it needs to change its phase with respect to space. The other is one which is changing its phase with respect to space. Other is with respect to time. This spatial orientation and the space orientation or change of phase with respect to space and time, both should be included. If you have a term called omega t, this will give you the change of phase with respect to time, beta into x or beta into y or beta into z based on the direction of propagation. Beta x, beta y or beta z will give you the change of phase with respect to space. So when you have these two things into consideration, then you call it as a wave. So basically, otherwise I'll explain, don't worry. Yes, Amit, already rolling. Already rolling. And one more subject on controls. Yes, Amit, I am with you, don't worry. We'll finish syllabus. We will finish syllabus. There is no doubt in that. And we will finish it comprehensively also. Just stay tuned. We'll have EM wave propagation 10, part 10, where we are finishing module 2. We'll finish module 2 there. So module 1 is done, module 2 is done, module 5 is done. Only 3 and 4 are left out. On Sunday I am starting 3. Okay. Transmission lines also we are going to start. And control systems will start from Sunday. Control systems on YouTube will start from Sunday. Archit sir has joined us. Alumni of IIT. He will join us. And he will take care of controls. As I told you, as I promised you, we are ready to gear up and complete the syllabi comprehensively. Let me explain you. So, if you consider a wave, yes, full comprehensive course. Yes, Amit. Control system, full comprehensive, everything full comprehensive courses only. We'll rock GATE 2023, don't worry. See, you are asking for theory, no? I'll right away we'll have some wonderful discussion. Just listen. We'll have some wonderful discussion. Just stay tuned now. We'll have the discussion. Very good, very good. If you draw a wave which is propagating, for example, along z direction, this wave, if you take the wavelength is a distance traveled to complete one cycle, which is lambda. So this distance is lambda. Half of it is lambda by 2. 1/4 of it is lambda by 4. This is 3 lambda by 4. This is the wave. No. I was discussing on, someone asked me about what we had covered in the comprehensive syllabi. I was discussing on the comprehensive syllabus. We'll cover MCQ, so okay. There is no mistake, dear Amit. I was just explaining what we had covered in Gate Conqueror. Will be followed by helical antennas MCQs. Okay. Now you tell me. Okay. Listen carefully now. We are not discussing on wave propagation, okay? We are not discussing on wave propagation. We will be discussing on MCQ on helical antenna. Good evening, Bhaskar. So now, yes, Amit, listen carefully. If this distance is lambda, and what is the time period? Time period is the time taken to complete one cycle, T, capital T. How much is time period here? T by 2. Here, T by 4. Here, 3T by 4. What is phase shift? Here, 0. Here pi by 2, here pi, here 3 pi by 2, here 2 pi. Now, yeah. Now you see, what is a wave, dear? Wave is something that changes its phase with respect to space and time. The change of phase with respect to space given by beta x if the wave is propagating in x direction, beta y if it is propagating in y direction, beta z if it is propagating in z direction. The change of phase with respect to time is given by omega t. Can anyone tell me why so? Anyone tell me why so? Or can anyone tell me what is the significance of omega? What is omega? Bhaskar, Amit, anyone? See, you might, omega is not new for you, am I right? It's an old customer only. You might have seen this omega in many of the subjects. Whenever you see omega, what do you understand? Frequency, Savan Kumar. Angular frequency. Omega is isotropic in nature. It is angular frequency. What do you mean by angular frequency? Means frequency we changing with an angle? Or what? See, I am not so knowledgeable like you. Tell me in simple language what is angular frequency? Savan, Bhaskar, Amit, anyone? IIT level answer, Amit. Angular frequency is defined as arc length swept per unit time. Omega is angular frequency. It means it will tell you the change of phase, with respect to time. Simple answer. Omega is angular frequency which is telling you the change of phase with respect to time. That's why the unit is, the change of phase is radian per time second. Therefore, it is radian per second. Unit of angular frequency is radian per second. Change of phase radians per unit time. Or the change of phase with respect to time. How? Can anyone tell me how? See here. Bhaskar, Amit, everyone. Time period T is 2 pi by omega. Am I right? Time period T is 2 pi by omega. Am I right? From this omega is 2 pi by T. Now if you take omega T, let us see what happens. When T is equal to 0, omega into T, T is 0. So when T is 0, time T is 0, phase is 0. When T is T by 4, omega T, 2 pi by T into T by 4, pi by 2, T is T by 4, phase shift is pi by 2. T is T by 2, omega T, 2 pi by T into T by 2. Phase shift is pi. Phase shift is pi. That means what? Omega T is giving you the change of phase with respect to time. measured in radians. Omega t measured in radians. The change of phase measured in radians. It is giving you the change with respect to time. Is that clear? So any wave must have omega t. Because a wave is one which changes its phase with respect to time. So any wave must have omega t. Am I correct? Yeah. Now, what is beta? Phase shift constant. It tells you the change of phase with respect to space. Beta is change of phase 2 pi with respect to space lambda. Therefore, beta is given by 2 pi by lambda. For example, wave is propagating along z direction. Then beta into z must give you the change of phase with respect to space. Not done, not done. Bhaskar, it is not done. Listen. I will tell once it is completed, again I will tell, okay? Beta z will give you the change of phase with respect to space. Now, when z is 0, beta z 0. Z means distance. When z is 0, beta z phase is 0. Z is lambda by 4. Beta z 2 pi by lambda into lambda by 4 is pi by 2. Z is lambda by 4. Phase shift is pi by 2. Z is lambda by 2. Beta z 2 pi by lambda into lambda by 2. Pi. Z is lambda by 2. Phase shift is pi. Omega t means angle. Omega t means angle only. Omega t is angle. Omega is telling you the change of phase with respect to time. Into time gives you angle. Omega t is an angle. But omega is telling you the change with respect to time. When you multiply with time, it will become angle. That angle is nothing but your phase shift. Now, Bhaskar, I'll clear. Wait, just wait. Okay? Now, beta z is equal to lambda by 2, phase is phi. That means what? Beta z is giving you the change of phase with respect to space. Omega t is giving you the change of phase with respect to time. So, beta z or beta gives you change of phase radian with respect to space meter. Radian per meter. That's why the unit is radian per meter. Therefore, beta unit is radian per meter. Omega unit is radian per second. Change of phase with respect to time. Beta is change of phase with respect to space. And a wave is one which changes its phase with respect to both time and space. Therefore, it must include both these terms. If you drop the electric field intensity equation, E is equal to E naught into e power j of omega t minus beta z ax. This is the expression for electric field for a wave propagating along positive z direction with electric field along x direction, magnetic field along y direction. Electric field along x direction, magnetic field along y direction, and the wave is propagating along z direction, which is given by beta z. So, very clearly. Now if you see this equation, your perception will be different, because you know that a wave is something that changes its phase with respect to both time and space. It must include omega t and beta z, and by seeing this expression, it is very clear that the wave is propagating in the positive z direction with electric field along x direction, magnetic field along y direction, because it's a transverse electromagnetic wave where electric field and magnetic field are perpendicular to each other. So by just seeing that equation, now you are able to imagine the wave, if I am not wrong. If you are able to imagine the wave, 99% of the problem is solved. You will start understanding waves. The moment you will not remember it just like an equation, but the moment you see the equation and you can imagine the wave, that means you will understand waves now. Otherwise, it is impossible to understand waves for any student. That's why students feel waves are very difficult, because we cannot by heart these equations. We cannot mug up. Not possible. Only thing is you should understand. Now you tell me, is that clear? By seeing the equation, are you able to imagine the wave or not? Everyone. By seeing the wave, are you able to imagine the wave or not? Why exponential? E power j theta formula, Bhaskar. This omega t and beta z both are angle. E power j theta. Wave is cos theta plus j sin theta. Sinusoidal variation. This is the reactance component. Got it? Good question, good question. Got it now? Let me know. Is that clear? Why exponential? Is that clear? Good. So actually wave is having sinusoidal variations actually, but it will have reactance component also, so it is customary thing to denote with e power j theta. Cos theta plus j sin theta indicating that it is having inductive reactance. E power minus j theta indicates that it is having capacitive reactance. Again, current leading, current lagging, all those concepts will come into picture. Current lagging, inductive, current leading, capacitive. Okay, clear? Good. So that's about wave. And the moment you see this equation, you should be able to know, or you should be able to imagine the wave. So wave is something that changes its phase with respect to space and time. Omega t minus beta z indicates the wave is moving in which direction? Positive direction. There is no use, but basing on the movement of current with respect to voltage, the wave will carry either inductive or capacitive reactance. If the current is leading, it carries capacitive reactance. If the current is lagging, it carries inductive reactance. It is dependent on how the voltage and current are related in the given wave. Omega t minus beta z represents the wave is moving in the positive z direction. Omega t plus beta z represents the wave is moving in the negative z direction. Is this clear? Omega t minus beta z, omega t plus beta z concept is clear? Let me know. Please let me know, dear. 1 second. Just 1 second. Okay, is that clear? Bhaskar, please react so that we can move forward. Minus for delay. Delay in what? Delay in what, dear? I'll just get back to you. Just tell me delay in what? 1 second here. I'm trying to reconnect the plug. Power plug, 1 second. Can you give me 1 second? Just a second. What are you saying, Bhaskar? Okay. 1 second. Power plug. Laptop power plug is loose. Okay. Fine. Got it. So what you're asking, minus for delay and plus for advance in equation. It's not about delay actually. It's not about delay. Omega t minus beta z means in positive z direction. Shall I explain about this, Bhaskar? Shall I explain about that? Please let me know. Shall I explain about that? You mean to ask why omega t minus beta z means positive z? Okay. See here. In the equation omega t minus beta z is there. What is omega t? Change of phase with respect to time. What is beta z? Change of phase with respect to space. For any given wave, this difference is always constant. Let be some k, which is nothing but your phase, which is your phase, which is constant. Okay. Can I say it or not? Can I say it in this way or not? Yes. Because omega t is change of phase with respect to time and beta z is change of phase with respect to space. Both are angle. The difference is constant, or phase shift is basically constant. So we can say that, no problem. If we differentiate it, omega into dt minus beta into dz, differentiation of constant 0. Omega into dt is equal to beta into dz. Implies dz by dt is omega by beta. What is omega by beta? Velocity v. Omega by beta is velocity v. Which direction? This velocity is in which direction? Positive to z direction. The movement is along the positive z direction. That implies omega t minus beta z means which direction, dear? Positive z direction. Got it? Okay. Omega t will tell you the change of phase, the phase shift with respect to time. Because in a wave, the phase will change with respect to both time and space, Bhaskar. The change of phase with respect to time is given by omega t, with respect to space is given by beta z. As I explained here, this explanation. Change of phase with respect to space is beta z. Change of phase with respect to time is omega t. This is omega t and this is beta z. Got it? Yes, please let me know. Is that clear? Similarly, if you have omega t plus beta z, the sum is also always constant, which gives you the total phase, which is always constant. This is change with respect to time. This is change with respect to space. If you differentiate omega into dt plus beta into dz, it's constant. Omega into dt is minus beta into dz. Omega by beta is equal to d by dt of minus z. Velocity, the wave is now moving in negative z direction. Therefore, omega t plus beta z, wherever you have, indicates the wave is moving in the negative z direction. Now you tell me, is that clear, Bhaskar? Please let me know. Good. So that we have discussed. We see EM wave propagation in free space. We discussed. Derive the equations for alpha, beta, velocity and beta for a wave propagating in free space. Again, for detailed explanation, please go through this particular playlist. In this playlist, a total of 9 videos and recording of 18 hours. Just please go through that. Second, we went for EM wave propagation in materials, sigma not equal to 0, epsilon are greater than 1 and mu are greater than 1, where we derived generalized expressions for alpha and beta, derived velocity, eta, loss tangent, dissipation factor, sigma by omega epsilon, loss tangent or dissipation factor, sigma by omega epsilon, and also we classified the materials into good conductors, good dielectrics, quasi-conductor or quasi-dielectric basing on the loss tangent value. And this loss tangent is given by tan of phi, where phi is 2 times of theta n, where theta n is angle of eta, intrinsic impedance. Got it? Again, for in detail explanation here, please go through this playlist. Please go through this playlist for in detailed explanation. Third one. EM wave propagation in good conductors. Good conductors means sigma is far greater than omega epsilon, or you can say sigma by omega epsilon is far greater than 1. So sigma by omega epsilon is greater than 100. Good conductor. And we derive the values like alpha, beta, velocity, delta, penetration depth, surface resistance Rs, and eta. All this were discussed in detail in EM wave propagation in good conductors. Again, all these derivations, wonderful derivations and formulas which are derived will be useful for both GATE and engineering services, Especially the derivations will be useful for engineering services and the concept will be useful for gate. Clear, dear? All this we had covered in this playlist. Then we covered EM wave propagation, in good dielectrics. Good dielectrics means sigma is far less than omega epsilon. Sigma by omega epsilon is far less than 1. Sigma by omega epsilon is less than 1 by 100. 0.01. EM wave propagation in good dielectrics. Here also we derived the expression for alpha, beta, velocity and eta. Any doubt, please ask me, dear. Then we are also seen EM wave propagation in perfect dielectric. Sigma is 0, epsilon r greater than 1, mu r greater than 1. In these cases of perfect dielectric, which are very important application point of view, we derive the expression for alpha, beta, velocity and eta. Please go through the playlist in detailed explanation and derivations of all this, useful for gate and engineering services. Is that clear? And then topic number 6 we had covered pointing theorem. Theory derivations are completed. What we have not completed is we need to solve previous year question papers or previous year questions plus practice questions in this. Theory is already completed. This is left out. In the next session, EM wave propagation 10, I will cover this. Along with this, two more topics are left out. One is wave polarization. Which is left out. The other reflection and refraction of plane waves. For both normal and oblique incidence and for both perpendicular and parallel polarization. And we will derive some important concepts like total internal reflection critical angle, and Brewster angle. These topics which I had marked in red, I will cover in, please stay tuned, I will cover in EM wave propagation 10. So once I cover this, module 2 will be done. Mostly I will add like 7 hours more to these videos, making it 25 hours of module 2. Module 1, remember, 40 videos and 50 hours. Module 2 will be 25 hours. Total in module 1 and module 2 we will have 75 hours. Total we will have 75 hours. Of course, module 3 is not done. Module 4 is not done. Module 5 is about antennas and optical fiber communication. We will deal optical fiber communication in a separate series. It's also very interesting concept here. Optical fiber communication, a very interesting concept. I'll try to explain in the most simplest way so that it becomes very, very simple for you people. So this is one topic that is there, for which we'll start a separate series. Antennas, we covered in the series called Antennas Mahamarathon. We covered it in Antennas Mahamarathon series, where again this is a very unique series dear, where everything about antennas is covered here. Everything, literally everything about antennas is covered here. Wonderful playlist, 18 videos, .38 hours of content is already recorded. So in Antennas Mahamarathon, this is a very unique series because, or a very unique playlist because it covers everything about antennas. That's why it's very, very special series. Antennas Mahamarathon, useful for gate and engineering services. Now you see, almost in 5 modules we are done with, 3 modules. Only 2 small modules are left out. We shall complete EMFT comprehensively. I will not take less than 200 hours here for EMFT. Already we have some good content. Already recorded content is around 106 hours. Minimum 200 to maximum 220 hours. Between 200 and 220 I will try to finish this module 3 and module 4 also. Is it clear? Let me know, is that clear? Everyone. In Antennas Mahamarathon, we again divided this into 2 parts. Antennas and wave propagation. Again, I can tell you one thing here, this is also very unique series because mostly On antennas, like you can find around 7 to 8 hours of content max. Unlike that, we almost have 38 hours of content on antennas and wave propagation. Under antennas, covered concepts like basic terminology related to antennas, current distribution in antennas, radiation mechanism of antennas, how antennas will radiate, radiation mechanism of antennas, in which we had covered single wire, two wire and dipole, and we are seeing the radiation parameters of antenna. Under radiation parameter, we are seeing terms like gain or simple gain, power gain, directive gain, efficiency, directivity, radiation intensity, and many more. All this we have learned under radiation parameters. So what we learned, like gain, power gain, directive gain, efficiency, directivity, radiation intensity, and so on, all that we have covered under radiation parameters of antenna. And in radiation pattern, we've seen concepts like main lobe, side lobe, nulls, first nulls, back lobe, front to back ratio, side lobe level, side lobe ratio. All this we had covered. The radiation pattern. This we had covered under radiation pattern of antenna. After which, started with antenna arrays. After which we have started with antenna arrays. We covered antenna arrays. Under antenna arrays, let's see, in 2-element array, how many cases are there in 2-element array here? Anyone tell me how many cases in 2-element array? How many cases do you have in 2-element array? How many cases under 2-element array? In 2-element array, it's in all the 5 cases. Case 1, distance between the radiators is lambda by 2. Phase difference alpha 0. And these elements are fed with of course equal amplitude of current. This combination will lead to broadside array. This will lead to what? Broadside array. Total electric field, it is given by E naught cos of psi by 2 normalized value cos of psi by 2, where psi is total phase difference given by beta d cos theta plus alpha, where alpha is phase difference due to path difference. Got it, everyone? Et norm is cos of beta d cos theta plus alpha by 2. So try to substitute beta phase shift constant 2 pi by lambda, distance lambda by 2, alpha 0, beta d cos theta plus alpha by 2 is 2 pi by lambda into lambda by 2 cos theta plus alpha 0 by 2. It is pi cos theta by 2. Pi cos theta by 2. Therefore, Et normalized is cos of pi by 2 cos theta. Clear? Now if you take one second. Theta is 0, theta is 90, theta is 180, theta is 270, Try to substitute and tell me the answer. Yes, everyone, try to substitute and tell me the answer. Yes, let me know the answer. Theta is 0, cos 0, 1, cos 90, 0. So here the output is 0. No output, output is 0. Here the output is 0. Next, theta is 90, cos 90, 0, 0 into pi by 2, this is 0, cos 0, 1, maximum radiation, this gives you maximum radiation, theta is 90, theta is 180, cos 180 minus 1, cos of minus 90, cos 90, 0. Cos 90, 0. Null. 270. Cos of 270, 0. Pi by 2 into 0, 0, cos 0, 1. Maximum radiation. What is this? This case of broadside array. This case of broadside array. Okay. Next. Under two element arrays, case 2. Under two element arrays, case 2. Distance is lambda by 2. Alpha is equal to pi. This case is a case of end-fire array. End-fire array, because here you are having progressive phase shift. Progressive phase shift. Progressive phase shift means phase shift which is proportional to distance. Lambda by 2 distance, phase shift is pi. That means it is proportional, like this. For lambda by 2 distance, phase shift is pi, proportional. For lambda by 4, pi by 2. For 3 lambda by 4, 3 pi by 2. In this way, there is a phase shift, called as progressive phase shift. So let us see. We know ET norm from the previous condition. We know ET norm is cos of psi by 2. Psi is beta d cos theta plus alpha. Beta is 2 pi by lambda. Distance is lambda by 2. Alpha is pi, substituting. Psi is 2 pi by lambda into lambda by 2 cos theta plus pi. Psi is pi cos theta plus pi. I want psi by 2. Pi by 2 cos theta plus pi by 2. This cos of pi by 2 cos theta plus pi by 2. Pi by 2 cos theta plus pi by 2. Trying to evaluate for different values of theta. Theta is 0. Theta is 90. Theta is 180. Theta is 270. Theta is 0, cos 0 is 1. Cos pi by 2 plus pi by 2. Cos pi cos 180 minus 1. This is in mod. So only positive values, remember. This is in mod magnitude. Therefore only positive values, okay? Is that clear? Only positive values, is that clear? So cos 0, 1, pi by 2 plus pi by 2, cos pi, cos 180 minus 1. This is in mod, so you get maximum radiation here, maximum. Next, theta is 90, cos 90 is 0, 0 plus pi by 2, cos 90 is 0, null. It results in null. Next, 180, cos 180 minus 1, minus pi by 2 plus pi by 2, 0, cos 0, 1, maximum radiation. Maximum radiation. This is the case of end-fire array. But the array fires at the end of the array. This case is a case of end-fire array. Let me check for 270. 270. Cos of 270. 0. 0 plus pi by 2, cos 90, 0, null. So this is the radiation pattern, which is an example for end-fire array. It's an example for broadside array. Case 3. Case 3. Distance is lambda by 4. Alpha is equal to minus pi by 2. Mod of ET norm is cos of psi by 2. Psi is beta d cos theta plus alpha. Beta 2 pi by lambda. Distance lambda by 4. Cos theta plus alpha is minus pi by 2. This is pi by 2 cos theta minus pi by 2. Psi by 2 is pi by 4 cos theta minus pi by 4. It's cos of pi by 4 cos theta minus pi by 4. Try to plot. Theta 0, theta 90, theta 180, theta 270. Yes. Find and tell me the answer, dear. Find and tell me the answer. Yes, find out here. Theta is 0, cos 0 is 1, pi by 4 minus pi by 4, 0, cos 0 is 1. You will get maximum radiation here. Next. Theta is 90, cos 90 is 0, 0 into pi by 4, 0, minus pi by 4, this minus cos of minus pi by 4, cos pi by 4, cos 45, 1 by root 2, 0.707. Theta is 180. Theta is 180. Cos 180 minus 1, minus pi by 4, minus pi by 4, minus pi by 2, cos of minus pi by 2, cos pi by 2, cos 90, which is 0. Next. 270, cos 270, 0, 0 minus pi by 4, minus pi by 4, cos of minus pi by 4, cos pi by 4, 1 by root 2, 0.707. Here you got maximum. Here we got 0. So this is the radiation pattern here. Very important case. That's case 3. One second here. Okay. Case 4. Distance is lambda by 4. Alpha is pi by 2. ET norm is cos of psi by 2. Psi is beta d cos theta plus alpha. Beta is 2 pi by lambda. Distance is lambda by 4. Cos of theta plus alpha is pi by 2. It's pi by 2 cos theta plus pi by 2. Psi by 2 is pi by 4 cos theta plus pi by 4. Cos of psi by 2 is cos of pi by 4 cos theta plus pi by 4. Theta is 0. Please find out and tell me the answer. Theta is 90. Theta is 180. Theta is 270. Very, very important here. Very important cases. Yes, start. Theta is 0. Cos 0, 1. Pi by 4 plus pi by 4. Pi by 2. Cos 90 is 0. 0. Next. Theta is 90. Cos 90 is 0. 0 plus pi by 4. Pi by 4. Cos pi by 4. Cos 1 by root 2. 0.707. Next. Theta is 180. Cos 180 minus 1 minus pi by 4 plus pi by 4 cos 0 1. Maximum radiation. Cos 270 0. 0 plus pi by 4. Cos pi by 4 1 by root 2. Drawing the radiation pattern, here maximum, here 1 by root 2, here 0. This is the radiation pattern here. Exactly opposite of this. Because phase is also got reversed. This phase also got reversed. The fifth case, one more very important case. Case 5. Distance is lambda and alpha is 0. ET norm is cos of psi by 2. Psi is beta d cos theta plus alpha. Psi is 2 pi by lambda. Beta is 2 pi by lambda. Distance lambda cos theta plus alpha, which is 0. Psi is 2 pi cos theta. Psi by 2 is pi cos theta. So this is cos of pi cos theta. Theta is 0. Okay, dear, please do it. Theta is 0, cos 0, 1, cos of pi, cos 180, minus 1 because it is a norm. The modulus only positive. Theta is 90, cos 90 is 0, 0 into pi is 0, cos 0, 1, maximum radiation. Theta is 180, cos 180 minus 1, cos of minus 180, cos 180 minus 1. It is in mod, so maximum radiation. Cos of 270 is 0, into pi 0 cos 0 1 max radiation. You get a flower shape pattern, very important pattern. Is it clear? Everyone, is it clear? These are the two element arrays that we have discussed. Under antenna arrays, we are having two element arrays. All the 5 cases I had explained now, which are very, very important for any exam that you are going to write. Clear? Please respond, everyone. Is that clear? Let me know. That was about two element arrays. Then we have discussed n element arrays. Under n element arrays, we discussed broadside array, end-fire array. Under broadside, the special case, also the end-fire, the special case. In end-fire array, the special case, end-fire array with increased directivity. Instead of alpha is equal to minus beta d, if you apply alpha is equal to minus beta d minus pi by n, we'll get end-fire array with increased directivity, which are also called as Hansen and Woodyard array. Under broadside, the special case that we have discussed is broadside array with non-uniform distribution of amplitude. With non-uniform distribution of amplitude, which is a special case of binomial array. The advantage of binomial array is side lobes can be completely eliminated, but the drawback is directivity will be reduced. The directivity will be compromised or reduced. So if you can make a trade-off between the side lobe ratio or side lobe level and the directivity, then you'll understand which array you need to go, whether linear array or binomial array. The important thing is, in the applications where tracking is required, if you are having a side lobe which will lead to false tracking, therefore in all the applications where tracking is required, we go for binomial arrays. For a binomial array, the minimum number of elements are 3 elements, not 2. Once you do the binomial expansion, that will be very clear. Why the number of elements are 3 but not 2 in a binomial array? If you want, I'll explain. Please let me know, dear. Please let me know if you want me to explain why 3 elements are there in binomial arrays. Why not 2? I'll explain, dear. See dear, the coefficients of binomial series which determines the amplitudes of current. The amplitudes of current is decided by the Pascal triangle. This is your Pascal triangle dear. 1 on both sides. 1 plus 1 2 and the dropped 1. 1 plus 2 3, 2 plus 1 3 and the dropped 1. N is 5 1 4 6 4 1. In this way a triangle is formed. You can see that there is a triangle forming. So the amplitudes of current must follow these things. But you know, binomial array is a case where the elements are having unequal amplitude. These are having equal amplitude here. Therefore, if you want to go for unequal amplitude, then minimum how many number of elements should be there? 3 elements. That's the concept. Fine. For the formation of this binomial array, the minimum number of elements are 3. Number of elements must be there, which will avoid the side lobes and decrease the side lobe ratio or the side lobe level. This we have discussed under arrays. Especially in the n element array case. Clear? Once the arrays are done, we went for 7 sisters. The 7 sister antennas are folded dipole antenna, Yagi-Buda antenna, the most important helical antenna, microstrip array antenna, horn antenna, parabolic reflector antenna and lens antenna. These are the 7 sisters that we have discussed, or 7 important antennas that we have discussed. This is also very special topic. On any YouTube channel you cannot find this. Very special topic. And to adding this, we had also discussed about resonant and non-resonant antennas. Under resonant antennas we had discussed about dipole and monopole antennas. Non-resonant we have discussed about V antenna, inverted V antenna and rhombic antennas. Besides these 7 sisters, besides resonant antennas like dipole and monopole, besides the non-resonant antennas like V, inverted V and rhombic antennas, we have also seen antenna measurements. These antennas, under antenna measurement, what's it? Radiation pattern measurement, radiation pattern measurement, setup required for radiation pattern measurement, under antenna measurements, impedance measurement and the radiation pattern measurement. In the radiation pattern measurement, you have high frequency method and low frequency method. In high frequency method, the primary antenna is kept constant and the secondary antenna is rotated on its own axis. In low frequency method, the primary antenna is kept constant and the secondary antenna is rotated around the primary antenna in a constant radius. So that is about the two methods for radiation pattern measurement. Two methods for radiation pattern measurement: high frequency measurement, low frequency measurement. Setup required and the methods. Then we have seen the measurement of gain and directivity. Under measurement of gain, we have seen methods like 3 antenna method, measurement of absolute gain by two identical antennas. Measurement of gain, 3 antenna method, and measurement of absolute gain by using two identical antennas done. And we know directivity phi max by phi AV. Phi max by phi AV, where phi AV is WR by 4 pi. Directivity is phi max into 4 pi by WR, double integral of phi of d omega. Now, you can clearly see that there is a double integral involved here. Therefore, in the measurement of directivity, we go for graphical numerical methods. One of the variable is kept constant in that particular procedure. And these graphical numerical methods that we are having are orange slice method and conical cut method. And besides this, we also discussed about wave propagation, which will be useful for engineering services preparation. The wave propagation, it's in principal modes of propagation, which are reliable modes of propagation or principal modes of propagation. Under principal modes of propagation, we discussed on principal modes of propagation, we have seen ground wave propagation, sky wave propagation, and space wave propagation. Under special modes of propagation, we went for scatter propagation. The scatter propagation we have seen tropospheric scatter and ionospheric scatter. We have seen duct propagation. Ground wave propagation, frequency up to 2 MHz. Sky wave between 2 MHz to 30 MHz. Space wave 30 MHz to 300 MHz. Special modes of propagation, tropospheric scatter propagation, tropospheric scatter propagation, (100 MHz to 100 times of it). 10 gigahertz. Ionospheric is frequency 25 megahertz to 60 megahertz. Ductive propagation is due to super refraction. Yes, frequencies between 300 megahertz to 30 gigahertz. These are the 5 modes of propagation, dear. Besides these 5 modes of propagation, we are seeing the derivation for refractive index of ionosphere. We got it as mu n sin I by sin r under root of 1 minus 81 n by f square. Refractive index of ionosphere. Then we had seen mechanism, radio waves bending by ionosphere. We have seen terms like critical frequency, maximum usable frequency, least usable frequency, skip distance, optimum working frequency. We discussed all this under the main category of refractive index of ionosphere. Then we have seen ionospheric abnormalities. Under ionospheric abnormalities, we had seen main topics like sudden ionospheric disturbances, ionospheric storms, sunspot cycle, and so on. All this we have discussed under ionospheric abnormalities. Then we derived the range of space wave propagation derivation. And also we derived expression for electric field strength or received electric field strength in space waves, which is 88 root P HDHR lambda d square. All this we have discussed under second half, that is wave propagation concept. So all these are covered in module 5, part of module 5, that is antennas and optical fiber communication. In this playlist of antennas Mahamarathon, you can find all these topics. Total 18 videos, total 38 hours. And we will be starting OFC very soon. Clear? Helical antenna is a dash antenna when it is operated in axial mode. Helical antenna is a dash antenna when it is operated in axial mode. When it is operated in axial mode, it radiates along the axis, highly unidirectional. It radiates along the axis. Therefore, the helical antenna in axial mode acts as non-resonant antenna. Helical antenna is famous for dash polarization. Yesterday also we discussed on this. Circular polarization. Helical antenna can be operated in dash modes. Normal mode and axial mode. Two modes. In dash mode, the radiation is perpendicular to the axis. Normal mode. Option A is the answer. Helical antenna is said to be normal mode when n, number of turns into length on each turn, is far less than lambda. Option A is the answer. Helical antenna. In helical antenna, if the spacing between the turns is 3 meter, circumference is 4 meter, length on each turn is this was the circumference, this is the spacing, length on each turn is 90 degrees, therefore this hypotenuse square is side square plus side square. Hypotenuse is under root of s square plus c square. L is under root of s square 9 plus c square 16 under root 25, which is 5. Option B is the answer. If the diameter of helical antenna is 3.14 meter, circumference pi into d, pi square meter. Option C is the answer. Yeah, if the spacing between the turns of helical antenna is equal to circumference, pitch angle alpha is given by alpha is tan inverse of h by c. Alpha is tan inverse of h by c, or tan inverse of c by 2 lambda. Alpha is pitch angle, which is tan inverse of h by c. S is equal to c tan inverse of 145 degrees. Thereby 45 degrees. Helical antenna is said to be in axial mode when circumference is approximately equal to lambda. Pi into d is approximately equal to lambda. Diameter is approximately equal to lambda by pi, or approximately equal to lambda by 3. So, what is asking? Helical antenna is said to be in axial mode if circumference is approximately equal to lambda, diameter is approximately equal to lambda by 3. Both the cases are correct. He is talking about circumference approximately equal to lambda. In which mode radiation of helical antenna is along the axis? Axial mode. It is in the axial mode. Rest of the questions we'll try to see it in the rest of the questions we'll try and see complete it in the next session. Fine. Unacademy offers two paid platforms. One is Plus subscription, other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in the form of live classes, weekly tests, structured courses, unlimited access, rank improvement batches, and crash courses. In Iconic, you'll get all these features Along with that, you get a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study material, personalized test analysis, study booster sessions, and study planner. Go for plus subscription or iconic subscription. I recommend you to go for no cost EMI. The total cost will be divided by number of months without any extra cost. And also you can use our team code KNR10 to get extra 10% off and complete team support. Don't miss it out. With iconic subscription, 1:1 live mentoring program is possible, increasing your chance of getting a top rank. Unacademy Light Test Series. Its launch date is March 9. First test test 1 starts from March 13. By using this code, you can save more like 20% for today, tomorrow and after tomorrow. For getting subscription, mainly you can use our code KNR10, which is our team code. Which not only gives you this extra 10% off plus extra 10%, total 20%, but also complete team support. If you have any doubt in your preparation journey, subscription or latest offers, dial here and talk to our counselor. Unacademy Ask a Doubt featured here, which is available on both website and app now, through which you can ask 3 doubts at a go, and total of unlimited number of doubts you can ask, and get the solution in your preferred language, and it is very easy to ask a doubt also. Just click, crop and submit. Super combo offer going on with every 2-year subscription, 1-year subscription for campus placement IT jobs free. For every 1-year subscription, 6-month subscription for free for campus placement and IT jobs. This is the rank predictor. Just sign in, go to gate landing page, click on the rank predictor, select your stream, select the session you appeared, paste the URL, you will get the response sheet. This is special class features where you have interactive live classes, polls for the learners, raise hand option, never miss a class when the notification is on, and you can download the lecture notes then and there, and you can access anytime and anywhere. These are the new batches. Vision, Gate and ESC 2024 started on March 9th. Electrical Explained Bilingual. Target Gate and ESC 2023 Electrical Explained Bilingual. Evolve Gate 2023 Electrical Explained Bilingual. Ascend Gate 2024 Electrical Explained Bilingual. Vision Gate 2024. Vision Gate and ESC 2024 for ECE Explained Bilingual. Target batch for Gate and ESC 2023 for ECE Explained Bilingual. Evolve Gate 2023 on 9th for ECE Explained Bilingual. Ascend Gate 2024 for ECE Explained Bilingual. So all these are the batches here. Thank you all for joining. We'll join for the next session where we'll discuss on EM Wave Propagation 10. Till then, have a good time.